launched this knowledge sharing process with a number of partners, and I would like to thank our colleagues from the USA, from Australia, from Canada, Quebec, and from New Zealand for providing financial sponsorship to this project. The schedule for today is very dense and hopefully very rich, and I would like to extend my sincere thanks to all the panelists and speakers. Some committee chairs, I see them in the room. Thank you very much. PIARC will be presented more in depth, I'm sure. There's lots to discuss, lots to learn, lots of knowledge that is already available. And at PIARC, we are committed to sharing this knowledge through reports, through online resources, such as our road safety manual, reports on road safety specifically, but also on tunnels and other topics. So I hope you'll bear with us, stay with us for the duration of the event, and come to our Prague Congress in less than 1 month to ask more questions. Thank you very much. Back to you, George.
Thank you very much. And welcome again. We would like to start with a very short introduction, what is about this PIARC Global Road Safety Knowledge Exchange. In fact, great. I think that we muted everybody, so we can start with the presentation of the small introduction. In fact, we know everybody, PIARC is very active in all areas of road development and operation, but most importantly, has a very strong component on road safety. The Technical Committee 3.1 on road safety, it is a part of ST3 and has a special focus on several issues on road safety. And that was the basis to start this initiative on putting in value in promoting this great work. Technical reports, the road safety manual, and several seminars are within the activities of PIARC road safety. And lately this year, there is this project on promoting road safety and all the knowledge gathered within PIARC technical work and technical committees, with special focus on low and middle income countries. However, the lessons are also quite important for all countries in the world. There is a special support by National Technical University of Athens and Austrian Institute of Technology to this initiative. There are 8 major road safety areas. We are going to deal with them, 4 of them today. And of course, there is always a special attention on road safety manual and road tunnels manual. We have this 1 year campaign. You have already witnessed already some posts and communication campaigns at the newsletter, the frequent newsletters of PIARC. And today we're going to talk about 4 key areas: road safety infrastructure, road safety tunnels, managing speed, and road safety data, where we highlight all the work of the Road Safety Technical Committee in a comprehensive way and useful for to everybody. So without saying more, please note that you can always ask questions through the chat during the presentation, which will be responded just after each presentation, mainly at the chat. But if someone wants to take the floor, can always ask after the presentation. And with this, I would like to welcome John Milton, the Director of Transportation Safety and Systems Analysis at the Washington State Department of Transportation, and who is the chair of the Road Safety Technical Committee, to talk us about road safety and infrastructure. So, John, you can take the screen. Okay, I think that we have an issue with John, so perhaps we might go for a small switching of the presenters, and perhaps we can start with Ingo Gaudinia to talk us about road safety tunnels. Ingo Gaudinia is head of section of the German Federal Highway Research Institute, BAST, and chair of the Tunnels Technical Committee. So, Ingo, we might start with you. You can take the screen.
Thank you very much. So now my mic is not muted anymore. So I was wondering that it's not working, but it works. So just let me share my. Okay, then I will start. I hope it will be fine. So then welcome to my presentation about road tunnel safety. I will start with a brief overview about the safety principles for road tunnels. I will talk a bit about the specific hazards we have in the road tunnels. So they are a bit different and a bit more serious than we have on the open road. A very important topic for tunnels is human factors. And I will also touch some road tunnel safety measures which could be implemented by everyone. And finally, I will give some recommendations and some advice for useful PIARC reports in this area. So let's start with a road tunnel safety principle. For road tunnels, there are special infrastructures. We have high requirements for safety and availability. The consequences of events in a tunnel, so if something happens, like a worst case event would be a fire, you have a very significant higher impact on with this event than you have on the open road. And tunnel safety is characterized by complex interaction of different aspects. You can see it here in the graph. Tunnel safety has an interaction, of course, with the tunnel user. So people driving through the tunnel, they must know how to behave correctly in a tunnel. Then tunnel operation is something which is very important to consider. So operation means the operator maybe from a control room operating the tunnel, and also all operational procedures defined before opening a tunnel. So this has a big impact on tunnel safety. Other big impact comes from the infrastructure. So the design of the infrastructure, the structural design, but also the components, the technical components installed for road tunnel safety are very important. And last but not least, the vehicles have an important role. So what kind of vehicles are going through my tunnels? Are these heavy goods vehicles, maybe transporting dangerous goods? Are the vehicles in good conditions? Are there any vehicles which could have a breakdown in the tunnel? So all these factors here are influencing tunnel safety. And I mentioned already high level of technical equipment in the tunnels, and this means a high effort for maintenance and repair, which is also a kind of important feature of road tunnels. So we have developed in PIARC a long time ago a so-called integrated approach to road tunnel safety. So this integrated approach starts from the planning of your tunnel system and then goes to the defining of safety features which are needed for the tunnel. So regarding the infrastructure and regarding operation. And these features go into a safety analysis. And this safety analysis could be, for example, done by a risk assessment. And if this safety analysis comes to the evaluation part, you have to check, is your safety level acceptable or not? And if it's acceptable or not, is checked against the minimum safety requirements from your legislation. And you have so-called safety level criteria and also socio-economic and cost-benefit criteria, which are important here. And then you have the evaluation. You can say the tunnel is afterwards safe and cost effective to operate. Then you can open your tunnel. And the next step would be, are there any changes? So you also have to question yourself, if you have an in-service tunnel, are there any changes in your tunnel? Have you done an upgrading, or are there new regulations for your tunnel? Is there a change in the usage of the tunnel, or are there some experiences which have been learned from the operation? If yes, the process will start again, and you will go in this loop and go through the process again. If not, the process will come to an end, and you can still operate your tunnel as usually. So this is the integrated approach, which is very important, and we have a very interesting and very detailed PIARC report on that. So safety level criteria I already mentioned. Structure, infrastructure and operational safety measures, I will come to this later. The socioeconomic and cost-benefit criteria I mentioned before is also a very important aspect of tunnel safety. The safety assessment techniques, we will go to this in the later part of the presentation. The risk assessment procedures we have as a tool for our road tunnels. And yeah, the stage of the tunnel life is also important. Are we talking about the planning stage, design stage, construction or commissioning stage, or am I in the process of upgrading and refurbishing a tunnel? Very important aspect is also the operating experience of the staff and the tunnel system condition. Of course, you have to maintain all your technical equipment, but also the structure, that everything is in good condition. This is also important for tunnel safety. So what could be specific hazards in road tunnels? So specific hazards are incidents which require special attention. If you are in a tunnel, you are in a confined space, you are not on the open road. So if something happens, it's not easy for people to evacuate. The air in the tunnel, the light conditions, everything must be controlled from a technical point of view. So it's not like on the open road. Therefore, we have some hazards which are important to consider in road tunnel design and management. These are collisions, fires, and release of dangerous goods. And I will go to detail regarding collisions and fires in the next slides. So collisions, these are events happening quite frequently in road tunnels. There are some positive factors reducing the probability of a collision in tunnels. So a tunnel could be a positive environment predicting collisions. You have very good controlled conditions in the tunnel. So if outside you have heavy rain or heavy snowfall, inside the tunnel everything is dry. You have light conditions. You have good ventilation if the tunnel is designed in a good way. So you have good conditions. So less probability of accidents. And you have a short and safe route with few junctions or no junctions, no intersections. So it's a very quiet, very linear way of driving through a tunnel. And you have no pedestrians and slow-moving vehicles normally in a motorway tunnel. So these are the positive effects regarding collisions. Negative factors increasing the probability of collisions in tunnels could be you have some obstacles. For example, the tunnel portal. This is a part of the tunnel which is prone to accidents. You have the tunnel wall, where you can collide with your vehicle if you're getting out of the lane. And this may also influence the driving behavior. Mostly we have a very narrow or very small road widths in the tunnel. So due to the high cost of a tunnel structure, you often have no emergency lane like you have on the open road. You have this change in light conditions, so you have to have a very good lighting system to avoid the black hole effect. Monotonous atmosphere, this is only relevant for very long tunnel, let's say longer than 1 or 2 kilometers. Tunnel conditions may cause a misjudgment of horizontal and vertical alignment, so sometimes it's not so easy to see where the road is going, what is the gradient in the tunnel. But we normally have a lot of installations now in the tunnels, a lot of light. So it's getting better, I think, to see the the road alignment. So fires are the most dangerous scenario you could have in a tunnel. The key parameters for a tunnel fire is speed of fire development and the fire size. You can see here some at least European fire curves which are applied for road tunnels. And what all these fire curves have in common is you can see a very steep rise of the temperature. If a fire happens in a tunnel, the temperature will rise very, very fast to temperatures up to 1000 degrees Celsius, which is very bad for tunnel users. And you have to be very quick to safely evacuate in case of a tunnel fire. These are fire curves, of course, for a worst case scenario. I will come to the different fire types later. So the factors influencing a tunnel fire will be the fire load. So is it a heavy goods vehicles, maybe loaded with wood? Technical conditions of the vehicles. Airflow is very important. So the ventilation conditions in the tunnel is very important for the influence of a tunnel fire. And of course, the design of the tunnel regarding fire is all the structural material fireproof, is the right operational equipment in the tunnel to have something to deal with the fire. So different types of fires in tunnels. If we have a vehicle defect, we very often have the so-called shielded fires. So these are fires developing slowly, and we have an opportunity to also extinguish this fire before it's getting very, very big, like in my previous slide with 1000 degrees. So if you have a shielded fire, it's maybe possible to extinguish in time, and you don't have this very big effects like shown in the previous slide. So fires after collisions could be tricky. Often we have some leakage of fuel. This could happen if you have a big accident, and this could lead to an accelerated fire development, and this could be very dangerous, and you have to evacuate very, very fast your road tunnel. I will now come to the human factors. This is a very special and very important part for road tunnels to consider. Design of tunnels and the operation should take into account human factors. This is very, very important. Some people have a feeling of anxiety if they drive through a road tunnel because of the confined space. It's maybe a bit dark, and therefore it's very important to inform users. So users must be informed how to behave correctly in a road tunnel. This is very important to have the user understand all the operational and safety equipment which is in a tunnel. This is very important to have safety campaigns in your country. There are also some measures which should be taken. So tunnel safety facility must be good, recognizable. So you need good lighting that everyone driving through a tunnel with 80 kilometers per hour or faster will see where are the safety facilities. Alarm signals should be provided by multi-redundant sources. So maybe you have a public address system in your tunnel and you have variable message signs or other equipment. So it's very important to have different kinds of approaching a user in the tunnel to say, to communicate with the user and say, if he has to evacuate, it must be very clear to him. So it's very important to have a good communication with the user. So human factors are also important for the operators. The operating staff is responsible for monitoring and controlling the tunnels. They are controlling a lot of tunnels normally. We have centralized operating centers working 24/7. One operator supervising 20, 30 or more tunnels. And it's important that they know all the procedures, that they are very good trained, that they know how to inform and warn users in real time, and that they have a good coordination with all the other rescue teams or first responders, which are needed if something happens in the tunnel. Very tricky this issue will become if you have a cross-border tunnel. Then you have to also think about joint trainings with the other country, and to have special procedures so that it's clear who has the responsibility for what part of the tunnel. Real-time communication. So I mentioned before, the communication with the user is very important. There are a lot of systems which are built into the tunnel for real-time communications. You can also you have also mobile connections in many tunnels. You have the public address system I mentioned, and for people without a cell phone, we still have these emergency call cabins which could be used. We have these cabins every 100, 200, 300 meters, depending on the country, and it's a lot of real-time communication equipment in the tunnels already existing. We have some new things like in-vehicle systems, which become more important in the future. I think the communication from the tunnel to the car could be done with the new technologies we have in the very new cars. So a lot of possibilities to communicate with the users, which should be used to increase tunnel safety. Tunnel operators and emergency services, also human factors are important for them. They have to consult and to cooperate during the tunnel design process. They have to have very good operational measures in place, contingency plans, and to prepare for all possible hazards and events which could happen in a road tunnel. Very important is to have familiarization visits and joint exercises to test the operational equipment and that the firefighters know how to use the different safety equipment in the tunnel. We have to define measures necessary to minimize the time required to mobilize the emergency services. And what is also very important is to learn from post-accident analysis, and so you can increase or include new things in your tunnel safety design. So what could be tunnel safety measures? We have measures preventing the occurrence of significant incidents. This could be a very important measure is the lighting of the tunnels, reduce the black hole effect, lane guidance aids, LED lights, ventilation system I mentioned is very important for the case of a fire. So we need a very good ventilation system to prevent a fire or to mitigate the effects of a fire. You have the same, you have also in other, on the open road, you have overhead signal system, you have a lot of variable message signs, and speed limits must be included in the tunnel, and speed control. In some tunnels, you have speed cameras to have the users using the right speed in the tunnel. This is very important. And preventive maintenance is important. So if something is happening in your tunnel, it's always good that you have a good maintenance plan, that in the case of an accident or a fire, everything is working in your tunnel. So you have to include good maintenance procedures. So mitigation measures, if something happens in your tunnel, you can have different parts of mitigation measures. You can soften the mechanical impact of a collision, for example, by using safety barriers. Very important at the portal of a tunnel. Avoiding secondary conditions is also something which is very important. So if something happens in the tunnel, directly close one lane or the whole tunnel tube to avoid secondary collisions and to become a big scenario which could be very, very dangerous. Yeah, detection devices for early warning of incidents is something which are implemented in many, many tunnels. Good is if you have different kind of detection devices to verify if something is happening. If you look here on this picture on the right, you see the fire detection cable you have in the tunnel ceiling, and you maybe have also a video detection system which could detect a fire. So this is also a possibility to have two different kind of detection systems for the same hazard, so you can very good identify what is happening or what is going on in your tunnel. Yeah, supervision by control center, I mentioned before, is very important. Ventilation to control the fire is a very important safety system which helps to mitigate the effect of a fire. Yes, measures supporting self-rescue. You can see it in the picture on the right. You need the emergency exits. In tunnels in Europe, you have a minimum every 500 meters, you have an emergency exit, which is going to the other tunnel tube or maybe to the outside. And you need good smoke management strategies to allow people to self-rescue. You have I remind you of the fire curve. So the fire is rising very, very steeply, very fast. You have smoke developments, which is increasing very quickly. So you need very good smoke management strategies to allow people 4, 5, or 6 minutes to self-evacuate in the case of a fire. Special attention has to be taken for tunnels with a high volume of heavy goods vehicles. For tunnels with high gradients or other characteristics, you have to have special measures in place. And I mentioned it before, public education, information campaigns are very important to educate the users. Yeah, measures supporting emergency response. These are also important measures. I will not go into detail here because I think the time is running quickly. The operators need to know their tunnels. This is important. Firefighters have to have regular training and have good cooperation with a local tunnel operator. This is a risk assessment procedure which has been published by PIARC, I think some 15 years ago. It's nearly 20 years ago. It's one of our bestseller reports where we have described the risk assessment procedure which should be applied for road tunnels, starting with the hazard identification, probability analysis of the consequences, and then coming to a risk estimation, risk evaluation against the risk criteria I mentioned also in the beginning. So your legal criteria you have in your country, and then if the risk is acceptable, this process will stop. If not, you have to implement safety measures and the process starts again. This is very briefly the basic process of risk assessment. And we have also a procedure for upgrading or improving the safety of existing tunnels. It's also published in a PIARC report. This is a procedure very similar to the risk assessment, how you can assess the safety level of your existing infrastructure. And if the safety level is not acceptable, you start implementing tunnel safety measures, additional measures, and then you will go on in the process again, and it will hopefully lead to a safe road tunnel. So finally, recommendations. What could we learn from all these different aspects I mentioned in my presentation? The integrated approach has been proved a very good approach. So this should be applied by you during the design of road tunnels, but also later in the operational phase. It's very important to take into account the human factors, not only for the users, but also for operators, firefighters, and so on. A safety concept is very important at an early design stage, and to provide and to also adapt this safety concept during the lifetime of the infrastructure. A good cooperation between the operator and the firefighting organizations is also key. Measures for prevention, mitigation, self-rescue, and emergency response. I've shown you some examples in the presentation. This must be adopted for the tunnel. And important is that all measures which have been implemented are well understood, not only by the operator or the first responders, also by the tunnel users. So it's very important to focus on the tunnel user. And finally, it's important to upgrade existing tunnels if they have a certain age and the equipment is outdated. It's very important to update these infrastructures. These are some PIARC reports which are relevant. I've copied you in this last slide of my presentation. You can click here and you will have the reports directly in your web browser. Finally, I would like to remind you of the upcoming World Road Congress in Prague. we will have a technical session on road tunnel operation and safety on Thursday in the morning. And in this session, we will have a presentation about the special challenges of road tunnel safety for low and middle income countries. So this will be presented by our colleagues from South Africa and India. I think this will be a very important and interesting session, and also a very important presentation dealing with this topic at the World Road Congress. So thank you very much, and I'm looking forward to your questions. So I didn't read all the
Thank you very much. Thank you very much, Ingo. It was great, just the right timing. First of all, we have a question, if you can see the chat, about approved methods of extinguishing electric car fires occurring in the tunnel.
Yeah, this is something we looked into during this work cycle. We have just published a report on that, a case study report by our working group led by Peter Sturm from Austria. We have looked into this hazard, and you can say the fire load is nearly similar to the fire load we have with conventional fires, with the electric cars, but it's harder to extinguish these fires. So for firefighters, you need different approach. You need a lot of water, a lot of time to extinguish a fire. So it's a challenge, especially for the fire brigades to deal with these hazards. For the tunnel user, it's not so different from conventional fires. So fire development is quite similar, and you have some little bit different toxic gases, but this is not the big issue. It's different, but the biggest challenge with these electric cars is for the fire brigades.
There is a similar question about electric car fires, but also just a suggestion that perhaps a discussion about upgrading tunnel infrastructure. If you can comment whether there is planning for guidelines for the development of specification for the upgrade of tunnel infrastructure.
Yeah, we have reports, PIARC reports dealing with this issue. I mentioned them in the last slide of my presentation. You have the links to the PIARC reports, and I think many countries already had these upgrading programs. So in Europe, we had these big tunnel fires in the tunnels in the Alps around the millennium, and we had a lot of tunnel upgrading since then. So we had a European directive issued in 2004, and afterwards in the next years, many European countries have to upgrade their tunnels. And I think if you're outside of Europe, this is also something which is it's important to regularly upgrade your tunnels according to the newest technical equipment and newest safety components which are required in tunnels. So we can provide you with a PIARC report on that, with the upgrading.
Great, thank you. And one more question about it says it's not 500-meter cross passage is too excessive for escaping and for firefighters accessing a fire.
The 500 meters is for the tunnel users in Europe. In Europe, the maximum distance is 500 meters for cross passages for emergency exits, and these cross passages are normally also used by the fire brigades to go to access the fire. So they're coming through to the other tube, and they could also access through these emergency exits the fire. But this depends on the procedures. So every tunnel could have different procedures for fire brigades, how they approach a fire, how they handle and how they deal with the fire.
Yeah, and a similar question whether the distance from one jet fan to another has to be uniform along the tunnel.
This is very much depending on the tunnel. So it's not the same for every tunnel. It's depending on the gradient. It's depending on the natural conditions outside the tunnel. So this is it's a very tricky and a very special question how to design a ventilation system. We have a report on that, which has been upgraded in the last PIARC cycle, so from 2016. And in this report, you find all the necessary tools and all the necessary recommendations to design a ventilation system for your tunnel. So it's not, you can't say you need every 300 meters, you need a ventilation in your tunnel. So it's not that easy. So it's something you have to design for every tunnel in special. But there are some specialists doing these design for ventilation systems. I think you have to consult some of these specialists, or just send me an email and I will give you some advice who could be a good partner to look into this issue.
Great. Thank you very much. We have no other questions. So thanking you for the presentations and the discussion. I think that it's time to go to the next presentation. I think that we still have this small issue with John Milton, who is trying to connect. So before solving this, may I ask John Barrell, International Road Safety Consultant and member of the Road Safety Technical Committee, to present about managing speed. So, John.
Okay, thank you, George. See if I can share my screen.
Will come now.
Okay,
Yes,
can you
we
see? Excellent, thank you. Right, what I want to talk about is managing speed for all road users. It seems that speed, inappropriate speed or overspeeding, is one of the commonest reasons, excuses, or contributory factors to serious and fatal collisions, particularly in low and middle income countries. And managing it for all users is particularly difficult because the infrastructure increasingly is designed for moving motor vehicles. I think the thing to note is that the road network is not new. It's been around ever since human beings could walk. It started out as individual tracks for hunting, for gathering, for communicating between settlements, and has gradually developed as we become busier and more mobile. Key change came with the introduction of the internal combustion engine, and journeys that used to take days or weeks can now be completed in hours. The consequence is that vehicles are moving much faster, they're moving on much straighter roads, and that creates problems for those who are outside the vehicles by and large. We need to consider all road users, and when they're using what is a variable road network, they need clear indications of what to expect, when to anticipate changes, and how to take appropriate action. So they need consistency. Consistency of signing, consistency of road layout, consistency of expectation on what to do, and have sufficient visibility to recognize those changes, to recognize those hazards, and be able to take appropriate action. They also need to understand what those features are. They need to be legible. They need to read the road environment, to be aware of who is around, what their actions might be, and how they can react appropriately. It is all about the road user being able to react appropriately and in sufficient time to deal with the conditions that's ahead. It needs to be done comprehensively, needs to be done consistently. But importantly, the road user needs to understand what is an appropriate speed for particular circumstances in order to negotiate the road network safely. If it is not credible, if they don't believe there should be a limited speed along a particular stretch of road, they won't do it. And the one time they really need it is when they will come to make mistakes. Traditionally, we have dealt with incidents as they happen and looked to correct specific problems. More recently, we have recognized that it is not necessarily the individual that it is fault. It is a systematic failure of the network as a whole. So dealing with a safe system rather than individuals is vitally important. And the safe system basically says human beings are fallible. We can make mistakes. So when we make mistakes, the system needs to be forgiving. We need to be able to make those errors and corrections without it having fatal consequences. So when there is a crash or a collision, the resultant forces that are in place need to be survivable. And the most vulnerable element in that system is the human being. Human beings cannot withstand severe stresses and severe changes safely. It needs to be done gradually. Those forces need to be reduced to a survivable level. And the classic chart is where pedestrians are involved. As soon as collision speeds exceed 30 kilometers an hour, there is a very rapid change in survivability. So at speeds in excess of 40 or 50 kilometers an hour, unprotected pedestrians or cyclists are more likely to be killed. The vehicle itself provides a degree of impact protection, but that is only valid at certain speeds, and the areas of protection around vehicles varies. Side impacts, collisions are survivable around about 60 kilometers an hour. Head-on collisions, anything above 70 or 80 kilometers an hour, leads to fatal injuries. So we need to shape and control our streets and roads so that they are safe for all road users, bearing those types of collisions, taking those into account. And there's essentially 6 basic collisions. The main one, particularly on a link or in a rural area, is loss of control. On a dead straight road, in perfect conditions, you would anticipate that drivers don't have a problem. Increasingly they do, whether it is tiredness, monotony, vehicle failure, they will lose control in the lane and potentially collide with the vehicle coming the other way, or if there are pedestrians and cyclists by the side of the road, they can injure them. They will also collide with roadside hazards. Equally, if visibility is poor, there's a risk of rear end collisions, and they need to be able to adapt to those collisions, those situations at an appropriate speed. And when you deal with intersections, clearly a side impact collision with a vehicle or with other road users crossing the side road is equally likely. And you can interact with slow moving vehicles and pedestrians, cyclists within the carriageway itself. Whatever is an appropriate speed needs to consider these different types of collisions and the likelihood with which they can occur. Trouble is, speed and collision severity are not linear. 15% increase in mean speed can lead to an 88% increase in road crash fatalities. Similarly, reduction in speed, a 50% reduction in crash fatalities, which is fine bearing in mind mean speed. But individual vehicles will travel at different speeds, and there will be a variability around the mean speed or the 85th percentile speed at which drivers choose to travel, because that is where they individually feel safe. Roads with low complexity, wide, straight, open roads with no intersections and very few vulnerable or slow moving vehicles are designed for drivers to reach higher speeds. And the risk of crash occurrence is mainly related to the difference between the speed designed as safe and the speed actually held by drivers as thinking, this is what I feel comfortable with, this is what I can deal safely with. The overall aim with the road network is to create a road where the varying speed parameters are all in balance. When we design a new road, we tend to deal with design speed. The speed at which we want drivers of vehicles to travel. The wider and straighter the road, the more lanes it has, the greater the forward visibility, restrictions on intersections, and low presence of pedestrian, cyclists, non-motorized users, then we go for very high design speeds, typically 120, 140 kilometers an hour. And that would like to be within the safe speed limit, assuming that head-on collisions have been removed and that the posted speed limit is in place to guide drivers at what is an appropriate and safe speed. It also needs to be credible, and it needs to match the observed speed, and in the design sense, to match the functional and desired speed of that length of highway. Getting all 6 of those parameters in balance is often the difficult part, because we need to limit the standard set of speed limits that are consistently applied. We can apply any number of speed limits we choose. The more speed limits you apply, the more frequently you change, the more likely you are that people will not recognize the need for them. And there needs to be an overall body or lawmaking process that sets speed limits according to safe, survivable standards. Posted speed limits that are in line with the function of the road. They're safe, self-explaining and intuitively, and importantly, clearly and consistently signed. The signing of speed limits is crucial to determining appropriate road user behaviour. So what is the safe speed? Essentially, safe speeds vary depending on conditions. If it's wet, if it's dark, if it's raining, then the safe speed will vary. For general road conditions where pedestrians are prevalent and there is the possibility of a mix between pedestrians and vehicles, you don't have well segregated footways, you are asking pedestrians to use part of the travel lanes or the carriageway to get around, then you're looking at safe speeds of around 30 kilometers an hour. Typically involved around schools and in some intense urban areas where you have a large number of intersections where side impacts are possible, uncontrolled or priority crossroads and T-junctions, potentially roundabouts. Signalised intersections tend to remove the side impact collisions because you're negotiating the same space at different periods of time. But all those uncontrolled or semi-regulated intersections need to be controlled within a safe speed of 50 kilometers an hour. Single carriageways outside of those situations, you can operate safely up to 70 kilometers an hour. As soon as you get above that, you need to look at duplicating the carriageway, creating dual carriageways to remove the possibility of the side and frontal collisions, by also introducing grade separated interchanges and particularly controlling access by pedestrians, cyclists, animals. In many low middle income countries, herded animals along large rural corridors present a major and uncontrolled hazard where vehicle speeds need to be reduced where they're in large numbers. And importantly, when considering the road, you need to look at its context. We tend to think of roads as just fulfilling a movement function, getting from A to B as readily and safely as possible. But inevitably, roads pass through a number of different landscapes, whether it's urban, semi-urban, rural. And the function of the road from a purely movement one to an access and sense of place where a lot of other activities take place is very fluid. There is no clear distinction between the mobility and land use activities of particularly arterials, collectors to locals. Local roads may front directly onto arterials, and the control of that road hierarchy and how we manage speed between them has a fundamental impact on the credibility of safe speeds and the adaptability of the road network to those speeds. So to get safe speed compliance, we need an operating speed that is clearly designed to be at or ideally below what is the safe speed. If the operating speed is well above the design speed or the safe speed, then there is a higher risk of accident and injury occurring. To do that, roads need to be self-explaining. Drivers need to understand from the way the road is laid out and the visual clues they have, what is expected of their behaviour on that particular stretch of road. So it reduces the gap between the actual or operating speed and the safe speed. Where roads are not self-explaining and drivers perceive them to be safer at a higher speed than they really are, then that is what gives rise to high numbers of fatalities and serious injury risks. The key to this is posting appropriate speed limits. Speed limits that give a clear indication of the safe and operational speed need to be clearly signposted to identify the limits to which that speed applies. In many low and middle income countries, you have a speed limit sign at the start of a speed limit change, but very rarely is there one at the end that then potentially denotes a safer speed beyond that. There is an assumption that whatever hazard had been there to generate the lower speed has now been passed, but there is no clear indication of the limitation of a particular speed limit. They need to be in the right place to reflect the road characteristics and not overused. Frequent changes in speed limit tend to a lack of believability, a lack of credibility on the part of the road user. And they need to be homogeneous over the road network. They need to identify the same sorts of characteristics. Few examples. These happen to be Middle Eastern ones, but they apply virtually across the globe. If we look at a freeway, where you're looking at a functional or desired speed of 120, maybe 140 kilometers an hour, with multiple lanes, wide paved shoulders, large recovery areas, and a protected median in the middle that prevents crossover accident. That will have a corresponding maximum safe speed and safe speed limit. Actual safe measured speeds are round about slightly below the 120 kilometer an hour functional and speed limit. The design speed is probably somewhere around 140 kilometers an hour. So in that instance, the safe speed is both credible and adopted, and no additional measures are needed in order to get a safe, compliant speed on that length of road. If we then look at an urban divided carriageway, where the design speed is around about 100 kilometers an hour, it is divided, it has multiple lanes, it has a footway down the side rather than a paved shoulder, but equally has a protected median. The functional speed is about 80. The safe speed, given the presence of the footway and the hazards in the median, is around 50 kilometers an hour. But clearly the perceived speed is between 80 and 100. So the safe speed is too low to be credible. In order to make this credible, you need to alter the road environment. Reduce the speed limit to 50. In doing that, you will need to apply a great deal of enforcement. And if this is typical of the road network, you want enforcement over the whole of the network, which is virtually impossible to achieve. So reduce the speed limit to maybe 80, introduce a barrier in the median and provide some protection or remove the footway. A mix of enforcement and physical measures around schools, which are prevalent for casualties, for parking, for a confused road network at school change times. You want the speed to be around 30 kilometers an hour. Current posted speed is 60. Given the road layout with narrow single lanes, areas for parking and a divided median, actual speeds are between 20 and 30 kilometers an hour. Safe speed is credible, but the posted speed limit is too high. To be self-enforcing, simply reduce the speed limit to 30 kilometers an hour to provide additional reinforcement for those few who exceed the safe speed, and you create a safe and credible road environment. So freeways generally meet safe speed assessment because they are wide, they are open, they are designed for high speeds, no pedestrian activity, and tend to be grade separated intersections. It is the urban dual carriageways that have a much more complex land use function either side, need for more crossings and more interaction with non-motorized users that require a greater design effort to match the safe speed and the credible speed. Middle East, many of these are urban dual carriageways which tend to foster higher speeds than is safe in these particular circumstances. Rural undivided carriageways tend not to conform to safe speed criteria because they're long and straight with very little land use impact. They have potentially wide recovery areas, but the risk of head-on collisions is prevalent. Single vehicle loss of control, making sure there is adequate recovery areas, and matching the posted speed limit to the environment is very difficult to achieve. When everything else fails, it is a case of convincing drivers that they need to travel slower by putting traffic calming measures in place. Critically, when the environment changes, install gateways, carriageway narrowings or horizontal and vertical deflections to provide positive encouragement to slow down. Roundabouts, whilst being an at-grade intersection that does provide conflicts, reduces the side impact by having collisions that occur at an angle rather than at 90 degrees, and vehicle speeds tend to be slower around roundabouts due to the horizontal curvature. Another way of on a straight road, but if you have horizontal curves and you lower vehicle speeds, potentially more in line with the safe speeds you want. When all else fails, there is enforcement. Enforcement is a dual tool, potentially. It is often seen by road users as a revenue collection means rather than a safety benefit. But increasingly, we are moving away from manual speed detection to automatic enforcement, either through point speed cameras or potentially average speed cameras, which have been proven to be particularly effective on large, long straights. Radar speed guns for intermittent speed enforcement tend to be at particular locations where hazards are known. Moving to the future, connected vehicles present a major opportunity for both speed management, control, and for enforcement. The technology that is coming into vehicles means it is potentially more easy to remotely control vehicle speeds. Whether drivers will favour that, but still try to override the automation that says I cannot go higher than 50 kilometres an hour on this stretch of road, despite the fact that I want to, may create further issues. But we are moving into an age where third-party control of vehicles is becoming more and more common. So to summarise on speeding issues, measures to enable speed limits to be complied with, even when they're not credible, need to improve the signs readability to make drivers more respectful of the law by education. Change the road environment, make it self-explaining, make it clear to drivers particularly why they need to travel slower. If all else fails, add enforcement. For credible speed limit, the road characteristics need to match the driver's expectations, and locally manage the road environment to improve that self-explanation. The reasons why the speed limit is in place need to be fully understood by drivers. They don't know why and don't see a reason and use the road regularly, they will repeatedly ignore what they see as the recommended speed. So speed management is not only about regulating speed, but also planning and designing appropriate road layouts to ensure safe travel speeds. Main countermeasures used are improving readability, road and road environment improvement, and say a last resort is enforcement. Main countermeasures used to increase safe speed are the physical characteristics and heavy modification of the road environment. Managing speed through behavioural change or speed compliance regulations could be done by enforcement, education, or financial penalties. So it tends to be the financial penalties as the main reasons why drivers dislike enforcement so much. Treating high-risk locations with traffic calming and speed reduction measures where there is a known problem. Often where there is a problem in one location, one that is very similar appears not to have any problem. And we need to fully understand why the same layout has particular problems in one location rather than another. Increasing technology will help and could well replace a lot of the physical efforts we put in place, but that will take time. Current vehicle fleet has an average age of 10 years. In low middle income countries, that can stretch to 20 years. If full speed control of vehicles doesn't come in for another 10 years, then we're looking at a 30-40 year time horizon before these sorts of technologies come in low middle income countries. It is a changing road environment and we need to adapt to it, but we need to be clear on understanding why the road users choose the speed they do. We understand road user behaviour, we can manage it far better and more realistically. Any questions? Thank you very much.
Thank you very much. It was very comprehensive, going from problems to solutions. and with the appropriate substantiation by PIARC work. There are no questions, but I do have one concerning speed limits, which have to be appropriate and corresponding to the road characteristics. Sometimes we put them higher, sometimes we put them lower than it should be, creating some bad impression to the driver. Could you comment about how we can set appropriate speed limits for the different road environments and the road characteristics?
I agree entirely. We have too much of a presence of saying there is a problem on a particular road rather than changing the road characteristics, which may be designed for 100 kilometers an hour. We put a 50 kilometer an hour speed limit in and expect the road user to adapt to it. If we want a change in road user behavior, then we have to adapt the road characteristics. If you have a 100 kph road, you need to narrow the lanes, put a degree of traffic calming in place. I will not suggest road humps, because road humps or speed humps on a 100 kilometer an hour road present their own safety issues, but certainly rumble strips or audible devices, widening the shoulder, narrowing the carriageway, reducing the number of lanes from 2 to 1, introducing parking, changing the behavior that happens on that stretch of road to make it more applicable for the road speed limit is the chief thing. You can't do it by imposing the speed limit alone.
Great, thank you very much. And if there are no other questions, we might proceed with the next presentation. Some technical issues were solved, and finally, John is with us. John Milton, the Director of Transportation Safety and Systems Analysis of the Washington State Department of Transportation, who is chairing the Road Safety Technical Committee, is going to talk about road safety infrastructure. John, again, apologies for the technical issues due to our responsibility. So you can share your screen.
And hopefully you're able to see that.
Yes, we see it.
All right. So as George was saying, my name is John Milton, and I'm the chair of the Technical Committee on Road Safety. And today I'm going to be talking about some infrastructure basic facts, infrastructure issues, infrastructure safety measures, and then some recommendations as we finish up. So first, about infrastructure safety fundamentals. When we look at the 1-star and 2-star roads, 88% of pedestrian travel is on 1 or 2-star roads. 86% of bicyclist travel is on 1 or 2-star roads. And 67% of motorcyclist travel is on 1 or 2-star roads. And when we think about that, that is a lot of challenge for those who are walking, biking, and riding in these less than safe environments. So what are some of the infrastructure issues that we see? What we're finding is that the current barriers to effective infrastructure treatments include cost. Many different locations, particularly in today's environment, we're seeing costs go up, and that is becoming a challenge for many countries. The issues with compliance. When we put things out on the road, they're not always followed. What we want to see, we don't always see. We're also finding design issues. Design issues can occur just because we have many challenges. All roads are not the same, but we have to go around what we're having to build for can change. That also affects implementation issues. And then sometimes the public just doesn't accept what we want to put out on the road for making the conditions safer. And then ultimately, maintenance can play an issue as well. When we look at monitoring some of the issues that we see with design, implementation, and maintenance issues, we find that monitoring, analysis, and evaluation, a very important component of safety management of the network, is typically omitted. Although it's required to understand whether or not you're meeting the outcomes and make changes if necessary, like I said, it's not always done. The assessment of safety performance impacts and the impacts of change is often overlooked. What might work over at that location won't work at the location I have. And there's different reasons for it. That evaluation allows us to understand what those differences are and then make them adjustments as necessary. And in most countries and cities, more than half of all road deaths and severe injuries happen on less than 10% of the road length. When we talk about compliance issue, we see lower levels of compliance with the road rules and a lesser respect for the rule of law in many low and middle income countries than we do for high income countries. This might be for issues of enforcement and also the necessity from walking from place to place may make us respect those laws a little bit less. Compliance of treatments by road user is usually a significant issue in low and middle income countries, and it is very likely that the treatment effectiveness will be lower as a result. Issues that suffer from lack of compliance are, for instance, roundabouts, resulting from a failure to give way, and even vehicles circulating in the wrong direction of the roundabout. At pedestrian crossings, we see failure of traffic to give way, and at times we'll see pedestrians also leave early before it's safe to do so. In pedestrian footpaths, we see obstruction and misuse by vehicles, including motorcycles using those to drive along. Signalized intersections, we see failing to stop. Shoulder sealing, for instance, a misuse as external lanes, parking, and roadside trading can occur at these locations. Off-road motorcycle paths, we see obstructions on the paths and misuse by inappropriate vehicles. When we talk about safety issues, road infrastructure is often the single most significant factor that contributes to the severity outcome of a crash. Single most important. Head-on crashes occur on undivided roads, while lack of footpath or safe crossing presents a major risk for death and injury for pedestrians. And this is often what we see in many locations, both in high and low and middle income countries. We see this lack of pedestrian facilities. For cyclists and motorcyclists, the lack of specific infrastructure features that ensure a safe journey, like cycle lanes and motorcycle lanes, leaves them vulnerable to impact. Let's talk a little bit about infrastructure safety measures. The UN Decade of Action really told us about what to do, how to do it, and who to do it, focusing on safe road infrastructure, safe road use, post-crash care response, safe vehicles, and multimodal transport and land use planning as to what to do. How to do it was legal frameworks, gender, technology, speed management, capacity development, to be focused on low and middle income countries, and providing the financing necessary to provide the safe road infrastructure. Who to do it was government, civil society, funders, UN agencies, and the private sector. The safe system approach was focused as the UN's second decade of action for road safety with a goal of reducing traffic deaths and injuries by 50% from 2021 to 2030. Adoption of the safe system approach is necessary to prevent fatal and serious crashes. Focus upon improvements in infrastructure and vehicle safety over the medium to long term while essential in providing a forgiving system. And as John also talked about self-enforcing roads, forgiving that provides for that forgiving system. Road infrastructure must be planned, designed, built, and operated to enable multimodal mobility, including shared and public transport and walking and cycling. For those of us just starting to address safety, corridor demonstration projects are a very effective way to improve safety to improve public understanding and to improve funding for those types of projects. Let's talk about a little bit about the safe system principles, and you'll see this vary from location to location. And this slide is out of the United States. Death and serious injuries is unacceptable. That humans make mistakes and that we need to account for those mistakes in the way we design and operate our roads. That humans are vulnerable and they're subject to injury. Responsibility is shared. We're all in this together, and that safety is proactive. We shouldn't wait for a series of fatal and serious crashes to occur before we do something. And that by building a redundant system, we're able to carry out and carry forward issues that we might see where other locations or other parts of the safe system fail. Safer road means avoiding crashes by separating users in space. By doing so, you're reducing the conflicts as you are when you separate users in time. Increasing attentiveness and awareness allows people to understand what is on the road and react to it in sufficient time. It's also about managing kinetic energy by managing the speed. Understanding how to do so and setting credible speed limits, as was just talked about, is very, very important to managing kinetic energy. We need to manage mass difference. For instance, separating people walking and biking from those in vehicles and lorries. Managing crash angles is critical to reducing kinetic energy. With infrastructure safety management, clear and defined policies relating to the delivery of this safe system infrastructures are required to drive road safety improvements. It's important to understand what you're doing and where you're doing it, why you're doing it. Standards, guidelines, and tools provide this, and they are a mechanism to translate policy into action. Care should be taken from borrowing policies from other countries to ensure that it fits local conditions. The priority for low and middle income countries should be a shift from human ways to assist ways as many roads as possible, starting with the main highways and corridors. This action would imply that road infrastructure improvements related to lane markings, pavements, distress irregularities, visibility of vertical signs leading to safer roads for both human-driven and automated vehicles. Assessment of risk should be undertaken for the entire network. It's necessary to understand what is out there and what to do about it. Although there are established approaches for identifying high-risk locations, training of key staff is required. For existing road networks where data is available, assessment of crash data should be undertaken to identify high-risk locations. But it's important to recognize that crash data is not always available, so there needs to be another mechanism to be able to proactively assess so that you can have proactive approaches should be adopted for impact assessments, road safety audits, safety inspections, and road safety assessment programs. Infrastructure for automation, and each country will see automation at different rates. Currently, only high-capacity highways, motorways, freeways have the features necessary for applying smart road classification. When building new roads, road designers should aim to achieve the highest smart level roads. Activities should be directed towards implementing and expanding the 5G coverage, or at least along their main corridors. And low and middle income countries and transport industry should be prepared to avoid being caught off guard and not to get left behind the global community. Now some recommendations. Develop functional classification and desired safety performance standards for each road user group at the geographic land level and road corridor level. Review and update legislation and local design standards that consider road function and the needs of all road users and specific zones. Specify a technical standard and star rating target for all designs linked to each road user and the desired safety performance standard at that location. Implement infrastructure treatments that ensure logical and intuitive compliance with the desired road speed environment. For instance, 30 kilometer per hour urban centers, less than 80 kilometer per hour undivided rural roads, and 100 kilometer per hour expressways. Undertake road safety audits on all sections of new roads, pre-feasibility through detailed design, and complete assessments using independent and accredited experts to ensure a minimum standard of 3 stars or better for all road users, based on the IRAP star rating method. IRAP provides an affordable solution for road safety audits and inspections and is recommended especially for low and middle income countries. Undertake crash risk mapping, where data is available and reliable, and proactive safety assessments and inspections on the target network with a focus on relevant road users' needs as appropriate. Set a performance target for each road user based on inspections results with clear measurable metrics at the attribute level, e.g. providing sidewalks. Infrastructure is a key priority for increasing road safety. The PIARC Road Safety Technical Committee provides up-to-date recommendations on the planning, design, implementation, operation, and maintenance of road infrastructure according to the Safe System approach to all road authorities and stakeholders. PIARC is engaged in promoting road safety all over the world and is committed to actively supporting safety in low and middle income countries. The new knowledge sharing campaign for road safety will be providing monthly updates. This is one of them, and on social media and on PIARC website for all essential road safety areas. And stay tuned for more actions and events. And these are just some of the relevant PIARC reports. Quite a few of them and more being produced every day. And with that, I'm more than happy to take any questions.
Thank you very much for this very comprehensive and concise presentation. We have one question at the chat, whether you could elaborate a little bit better about forgiving system, forgiving environment, perhaps of this.
An example of forgiving environment would be one which accounts for the safety of the road user, particularly the severity, and would have systems in place that provide for reduced crash energy. For instance, roadside safety hardware. It might have breakaway signposts that provides for crashes related to motorcyclists as well as vehicles, that understands that when people get in crash, they're vulnerable to the injury and that we need to do what we can to remove those crash forces from the system.
I have also a small question, whether what is different when we're having strategies on infrastructure safety improvement between urban and inter key difference?
The key difference in many of those environments, George, is really often related to speed, but also the density of walking and biking traffic can change quite a bit. We'll see in those locations, in those transition areas, that people don't always adjust their driving behavior, for instance. Their expectations don't change in a way that we want them to. They may overdrive, for instance, in the urban environment, having just come out of the suburban environment. Many locations in the suburban environment don't have the same access control. So the potential for angle crashes is much greater. The speeds are higher, so the vulnerable road user crashes can be much higher as well.
Yeah, this is a fundamental link between also with the previous presentation on speeding. Infrastructure and speeding are correlated in terms of both design and operation and management. And this is heavily highlighted at the PIARC road safety manual, but also in all the work of PIARC. And a remark is that speeding is always underestimated in road safety.
Yes,
So
and
with this,
excessive
if we
speed.
don't, yeah.
And George, I would add that excessive speed in suburban environments is often an issue as well. So we see people going through the urban into the suburban and really picking up the speeds, and compliance becomes a much greater issue.
And with this, we thank you very much. It was very, very interesting. Repeating that all the presentations and the recordings will be available soon at the website of PIARC, and you will receive a message when this will be available to be alerted and being able to download them. And now we can proceed with the fourth presentation. It is about road safety data. We're going to have this presentation by Kauter Marta, the French Secretary of the Road Network Operation ITS Technical Committee, which will dig on road safety data. Kauter, the floor is yours.
Thank you, George. I will share my presentation, please.
Yeah, it's coming. We see it very well.
You see it?
Yes.
Okay. So I will speak about data, their importance, how they can be collected for a better use in low and middle income countries with limited resources, but also in more developed economies with different needs and priorities. I will explain why we collect data. I will speak about data types and different collection methods, road conditions and maintenance-related data and methods, traffic-related data, data on travelers' behavior, data from connected and autonomous vehicles, technologies, ITS and data, road safety-related data, and then disaster management data. After this, I will discuss data collection methods, opportunities, and challenges. And then I will give some recommendations. Why we collect data? We do it to keep roads safe and in good condition. And because reliable and accurate road safety data is essential in planning effective safety policy and treatments and monitoring performance. So why we collect data? We need it to have accurate and to make better decision in a strategy of and politic of road safety and manage roads also. This was shared by John also, and it is defining the framework that was defined to manage road safety. It defined what to do, how to do, and who to do it. And it interferes a lot of things, which is safer roads, safer vehicles, safer road users, and OSHCRAS response also importance. United Nations second decade of action for road safety with a goal of reducing road traffic death and ensuring by at least 50% from 21 to 30 was involved in the same safe system approach. The adoption of the same system approach is necessary to prevent fatal and serious crashes. Data collection and analysis can facilitate the maintenance and management of the road network and provide stress-free journey to road users. Strengthened data collection methods, locally and nationally, contribute to improved evidence-based policies on vulnerable road users. same system approach, the same system have some principles that assume that death is unacceptable. Human can make mistakes even when we have very good conception of road and well constructed. Humans are vulnerable. People cannot live for more than 50 kilometers per hour, cannot survive. I was in today, data collection can facilitate and maintenance and management of road. Strengthening data collection method locally and nationally contribute to improved evidence-based policies on vulnerable road users. Okay, next slide, please. Yes. Here is to say that death and injuries on the road are unacceptable, and human beings are fragile, and they cannot survive for impacts occurring at speed excess 50 kilometers. And all the responsibility is shared between all actors of road, designers and road users. We believe that accidents can be avoided if a proactive approach is taken, and redundancy is crucial. Next slide, please. Why it's important to collect data? We need these data. While some road crashes are predictable and thus preventable, effort to reduce crashes in developing countries are further hampered by lack of accurate crash and casualty data. Low and middle-income countries' road administration struggle to successfully adapt efficient ways to manage their assets due to limited resources. Indeed, data collection helps governments to more effectively prioritize funding, monitor the impact of investments, and strengthening inter-agency collaboration and efficiency. And then improved access to data on the effectiveness and cost involved in establishing intervention can lead to ongoing improvement and support for their broader application. I will give here some data types and collection methods. Next slide, please. Next slide. We collect data related to road condition and maintenance. So we find inventory data and road condition and maintenance data. The inventory data for road and road assets are used as benchmark by transport authorities for evaluating and prioritizing roads projects. Asset management system and solution useful if the quality and quantity of asset data are reliable. To collect them, we can use in-vehicle automated or semi-automated methods, highway inventory data, GPS data collection, logger, robotic total station, electronic distance measuring systems, mobile LiDAR, combination of video photos with aerial imagery. For the road condition and maintenance data, next slide, please. It can be done in vehicle sensor, essential components of any vehicle, which can improve vehicle performance or monitor its operation and the status of its parts. It can enhance the driving experience. We can do it with smartphones. For this, there is accelerometers capturing variation in movement caused by the road surface. We can do it with unmanned aerial vehicles or system drones, popular data collection method for road condition and maintenance management. This one is low cost, readily available, and efficient, and can reach remote location, therefore safer. It can be other fixed sensors, recorded signals, acoustic signature, and for winter maintenance, it can be thermal mapping forecasting models. Next slide, please. Traffic related data are important for smart transportation, which is cost-effective and significant component of smart cities. It is important because the principal challenge is traffic congestion due to increase in vehicle numbers and population and a changing balance of transport modes. The aim is for traffic to flow smoothly and to keep travelers better informed. To collect traffic data, we can use traditional sensors, smart sensors, which can provide real-time traffic information, cameras, CCTV system, and GPS signals, which provide data on road occupancy, vehicle speed, accident detection, traffic collision, and even weather info. And we can use also unnamed aerial vehicles. Next slide, please. It is important to get large-scale data on travelers' behavior. People actively participate in the process of recording data using technologies such as GPS systems, cellular networks, social media service, automated fare collection system, smart cards. All these have the benefits are to have modern traffic management and control strategies, robust vehicle detection system, mining mobility patterns, travel model analysis, to have information about incident detection, air quality measurements, and urban planning and emergency systems. Also, it's important for them. Next slide, please. We can collect data from connected and autonomous vehicles. In fact, embedded electronics account for more than 30% of the cost of a vehicle, including a multitude of sensors and actuators, various computers, engine control units, and internal digital networks of interconnectivity. These systems provide road condition data, traffic management data, safety data, can also be used for identification of intersection with high levels of variability in sudden changes in driving behavior prior to the occurrence of crashes. Technologies can be helpful for data also. Intelligent transport system and connected vehicles together with the Internet of Things provide more efficient and sustainable transportation systems that minimize the impact on the environment. But ITS has some constraints, such as political environment not suitable for data sharing and exchange, privacy issues related to data publication and distribution, lack of policy and governance to control and regulate information exchange within different operators. Data can be generated for and from social media also. People tend to share traffic information with a large audience. Thus, traffic control organizations started using social media. Types of data generated can be traffic forecast and event detection. It is also for journey information. In generally, social media used are Twitter, with automatic detection of traffic events using Twitter data mining, and then Facebook. Data source for social media is highly unstructured and is of massive volume and therefore requires complex processing methods. Next slide, please. For road safety related data, accident detection data aim to timely inform emergency services about the location of an accident. So data can be generated by sensors, smartphones, GPS and GMS, ultrasonic sensors. Road safety data support for crisis management in the occurrence of events, accident and damage, and ongoing traffic monitoring. using data from unmanned area vehicles also. We can speak also about disaster management data. A greater focus is required on the interaction of disaster management activities with the public to produce better results instead of prioritizing only making infrastructure safe. To collect data for disaster management and disaster relief, we can use satellite images, meteorology, cameras, vehicle detection, and GIS. Data collection methods, approaches, and the challenges are summarized in this table, please. Yes. In the first column, which is on the left, we can find the collection method. In the second column, the benefit of the methods, and then in the right column, and then the improve that can be done to make better use with these methods, such as reduced tailored of information. We can improve it. We can focus beyond road inventory. It's good to cover the full range of highways, integration of information from into existing IT infrastructure. We can have better alignment with wider management of airspace surrounding road infrastructure. This requires skills to understand, to analyze, and utilize the data. It needs also the use of approaches such as keyword extraction and machine learning based models. The management and analysis of big data, it's important also for this to manage all this data. It's important, the reliability and security of the data flows is crucial also. Next slide, please. It is important to collect accurate data. The main step to improving data quality include reviewing of variable definitions, ensuring definitions are simple to understand and apply, reinforcing the need to report data, for example, make it a legal requirement, improving data collection tools, collecting accurate location information, improving training of police and data entry staff to register better information about crashes, ensuring data collected is accurate and reliable through quality assurance measures. Next slide, please. We can give some recommendation for crash data in low and middle income countries. Yes. So we can say that crash data is important for infrastructure management in low and middle income countries, and the collection and analysis of crash data among road safety audits or road safety inspection is widely applied approach to manage infrastructure to assess the risks. So for low and middle income countries, crash data may not be reliable or available. Surveys and other data sources to measure and monitor road safety are needed. When crash data is analyzed, an understanding of crash causation factors needs to be given. A crash is not a result of a single cause. Contributing factors to crashes have to be examined to identify the issues. When using crash data, it is important to define the crash location and the time period to be logged at. Usually we use 3 to 5 years, but for low and middle income countries, a pattern could sometimes be recognized within 1 or 2 years. Next slide, please. Yes. Data is a key factor to evaluate investments. This is especially important with limited budgets, as effectiveness of road safety measures should be demonstrated and inefficient use of limited funding or an increase of crash risk should be known. We have to remain in mind that data quality is important. For example, a false low number of casualties will reduce the importance of road safety as a public health issue, or misleading information can lead to ineffective decisions being made. For example, investing money elsewhere in a road network. So PIARC is boosting road safety in low-income countries. It recognizes the importance of data, is engaged in promoting road safety for all over the world, and committed to actively support safety in low and middle-income countries. All these actions contribute fully to the success of UN Decade of Action for Road Safety. So we are in this sharing. Okay, thank you for your attention. I will be here for your question.
Thank you very much, Kauter. It was very insightful. I see that time passes. There are no questions. Of course, I have a question. If I could add, and this question about again is about the role of speed and the necessary data in terms of KPIs to explain the crash phenomenon by knowing the speeding levels in every road. How important are the KPIs?
It is important to have all this information because it can lead us to make better decisions and better planning and for road assets and road maintenance. Yes, they can constitute, all these constitute the KPIs for safe road safety issues.
Great. I see one more remark at the chat, but it is about driving license, not a direct, and it's not a question. It is a very nice statement about the role of robust driving licensing process, which is very, very useful. So with this, I would like to thank you a lot, Kauter, for this very comprehensive presentation about data.
Thank you.
Perhaps I just share my screen with a final a couple of slides for as a conclusion. You see my screen. Just to highlight that PIARC provides comprehensive infrastructure safety solutions through the PIARC Road Safety Manual, which is easily usable worldwide. And this is coupled also with the Tunnel Safety Manual as a great reference globally, low and middle income countries, but all over the world. Second point is that managing speed through behavioral change or speed compliance regulations could be achieved by several measures, including education campaigns and different enforcement types. And of course, crash data, it is the basis for every analysis, and it's highly important for infrastructure management, especially in the low and middle income countries, as the collection and analysis of crash data is a widely applied approach to manage infrastructure and assess the risks. So PIARC is engaged in promoting road safety all over the world and committed to actively support safety in low and middle income countries. This new knowledge sharing campaign for road safety provides monthly updates on social media and on PIARC website for all essential road safety areas for the whole of 2023. We have the next webinar on September 15th covering road safety management, VRUs, human factors, and vehicle safety. And of course, don't forget, early of October, we all meet in Prague for the PIARC Congress. And with this, if there are no other questions, anything else to be said? We are just in time. We concluded a very nice 2 hours webinar. We are heading for the next one, and keep tuned for all the activities about the promotion of road safety by PIARC this year and always. Thank you very much. Have a nice day, morning, evening, afternoon, night, everywhere. Bye-bye.